Hey everybody, I'm Andrew Brogdon from the Flutter team, and today I'm going to show you how to quickly bring a Flutter app to life with Cloud Firestore. If you haven't used it before, Cloud Firestore is a NoSQL document database that simplifies storing, syncing, and querying data for your apps at a global scale. It's also a great way to put a backend on a Flutter app without the hassle of spinning up your own servers. Let me give you an example. Say you're starting a band, and you and your bandmates can't agree on a name. You play remixed glam folk disco glitch metal and can't find anything that captures your essence. So you decide to do a survey. You'll make an app that displays a list of potential band names, and then you and your bandmates go out and show people the list. They tap on the names they like, and your app keeps track of how many people vote for each name. Putting together the UI for something like that is actually pretty quick in Flutter, as you may have seen in some of our other videos. But you also need a backend data source, shared between all the devices running the app. How can you build one and handle issues like security, connections going offline, and all the rest of that stuff? This is where Cloud Firestore can help. With it, you can create a collection that'll track the possible band names and their popularity. Then you integrate the Flutter Firestore plugin into your app and build your widgets using data from that collection. The app sends new data back in response for UI events like button taps, and Firestore handles the rest of the details. It persists the new info, sends updates to all the other instances of the app, and keeps everybody on the same page. Alright, so that's the plan. Let's imagine you've already done that first step of creating the UI with mocked up data. How quickly can we get it working for real with Firestore? Well, step one is to create a Firebase project. You could do this in the Firebase console. And I'm just going to call this one Band Name Survey. And click Create Project. And then a few seconds later, it'll be good to go. Cool. Now Firebase asks you to register the individual apps for your project. And here you can see me registering an Android one. There we go. Click Register App. And make sure you grab the config file right there when you do the registration. I'll show you what to do with that in a second. Once you have an app registered, you'll see this screen for your project, and you can use this button to add a second app. I'll use it to create an app registration for iOS. Flutter can build for both platforms, and if you plan to take advantage of that and release on both, you actually need to register two apps, one for each OS. One thing to note, when you create a new Flutter project in Android Studio or Visual Studio Code or whatever, you're asked for an organization name in reverse domain order. This, along with the name of the app, ends up as the package name for Android and the bundle ID for iOS. So when Firebase asks for those pieces of info, that's what they are. If you can't remember, just open the underlying Xcode project or Android manifest in your project source tree, and you can find what you need. Okay, with the apps registered, let's get Firestore going. I'm going to go over to Database under Develop and choose Firestore as my project's database. I'll leave it in test mode for now, hit Enable, and in a few seconds, once the spinner stops spinning, I'll have an instance of Firestore that I can start playing with. Cool. Now it's time to make a collection. I'll just call it Band Names and hit Next. And this will hold a document for each possible band name. Let's see, and for my first document, I'll just auto ID it, and I'll have the first field be called Name, and that's a string, and for the first name, how about Jam and the Angry Biscuits? There we go. And I need another field to hold the number of votes, so that's a number, and I'll start off with 0. Let me hit save here. And there's my record. All right, so that's one. Now let me go ahead and add 3 more records using a technique I like to call fast forwarding through pre-recorded footage. So there's 2, there's 3, and there's 4. My collection is ready. At this point, you've got a working backend. The next step is to get your app talking to it, and for that, you'll need the Cloud Firestore plugin for Flutter. All right, you may remember those config files we downloaded earlier from the Firebase console. Time to get them in place. I'm going to drag the Android configuration file, Google Services JSON, into the Android/app directory in my Flutter project source. Next, I need to get the Firebase Gradle plugin for Android in place. Now, Android Studio's Firebase Assistant can actually help you with this, but in case you're using Visual Studio Code or some other editor, I'm going to show you the manual way. Just open the build.gradle file you find in your Flutter project's Android directory, and then add this line for the Google Services plugin to the dependencies section. Then open the app level Gradle file at android/app/build.gradle, and all the way at the bottom, add a line to apply that plugin. And it's com, Google, GMS, and then Google-services. Cool. All right, for iOS, I'm going to open the underlying Xcode project created for each Flutter app. It's called Runner, and I'm going to open the workspace file itself, since Flutter uses CocoaPods. Once that's open, I'll drag the property list file downloaded from the Firebase console into the project, and it'll go right in that Runner folder. Cool. So that's the last platform-specific thing, which means I can spend the rest of my time in Flutter code. Let me open this project's pubspec file. This is the YAML file that lists a Flutter project's metadata, including its dependencies. And I'm going to add the Cloud Firestore plugin to the list. And once I've got that, I'll do a packages get from the tools/Flutter menu. That'll pull everything down and make sure I've got the Flutter code and native dependencies in place to use Firestore. So, with the Firebase config files in place and the plugin imported, this app is ready to start talking to Firestore. Okay, with the Firestore collection created and the plugin built into your app, the next step is to code the app to use live data from Firestore when building its widget tree. Now we're starting with an app that's been mocked up using hard-coded values, so most of the UI code can stay just as it is. You just need to pass live data into the build methods. Let me show you how it works. Okay, so here's my app running on an iOS simulator and an Android emulator. And it's all based around this list view, which displays a row for each potential band name. And there's a function called buildListItem that builds out the widgets for each row. The first thing I need to do is get the mock data out. So I'll scroll up, and I'll take out this mock class and the list of mock band names. There we go. And I also need to import the Dart code for the Firestore plugin. That's done at the top of the file. So I'll just add an import statement. And Cloud Firestore, there we go. Let me come back down. I'd like for this list view to display Firestore data, and I need it to be rebuilt whenever there's a change to that data. So I'm going to wrap it in a really handy widget called Stream Builder. The Firestore plugin provides a snapshot stream for each collection, which I'm going to use here. It's basically a running stream of updates that emits a new value whenever the data in the collection is changed. I'm subscribing the Stream Builder to it, and so it'll rebuild its children whenever there's an update. And rather than a child, Stream Builder takes a builder function as one of its properties. It'll call this function to rebuild its child widgets whenever the data in the stream changes. Many of you watching probably immediately recognize this as reactive programming, which is a pattern Flutter is designed to support. Alright, now when I launch the app, Firebase won't have had a chance to connect yet, so I'll get a snapshot that doesn't have any data. In that case, I'll check for it and just return a text widget that says loading. If the snapshot does have data though, I'll use it to return a list view, just like I was doing before with that mock data. And format that up. Cool. I'll base the item count off the number of Firestore documents in the collection snapshot, since I have one document for each name. And I'll need to change the buildListItem function to take an individual document snapshot instead of a mock data object. There we go. All right, let me scroll up to buildListItem, and I'm going to replace this mock with a document snapshot parameter. And then I can use that to get the right band name. There we go. And I can get the vote count as well. All right, now when I run this code, I get a bunch of names and zeros, which is the right stuff. Plus, if I go back into the Firestore console, I can now mess with these numbers and see the app react to the new data by automatically updating the widgets. So this is definitely live data. Okay, the only thing better than reading live data is writing it. So the last step is to make the list tiles on tap handler increase the vote count for that particular band name. As you'll see, now that everything else is set up and working, it's actually pretty quick to implement. Okay, so I'm back in buildListItem, and I need to put some code in this onTap function that'll increment the vote count. So I'm going to use my document snapshot to get a reference to the live Firestore document and then update it with an incremented count. This is a slightly naive solution, and I'll get into that more in a second, but it does work. So when I do a hot reload now, I get this, and I could start tapping away. So I tap on the iOS side, you can see the Android side updates. Tap on Android, iOS update. I could do this all day. Cool. Like I said though, this isn't a robust solution. I'm incrementing data that could be stale if some other instance of the app has updated the collection just before. So let's replace this with a transaction and do it atomically. I can actually ask Firestore to run a transaction for me, and then I'll give it a function to execute within the scope of that transaction. And I'm going to mark it async because I'm going to need to await on some things. So within this function, which gets the transaction as its only argument, I'll first get a fresh snapshot of the data for the document. So a fresh copy of that vote count. And then once that's done, and I'm awaiting because these methods return futures, I'll do an update using the document reference from the snapshot and an incremented vote count that I know I can trust. There we go. All right, now when I do a hard reload, I get an app that mostly looks and acts just like it did before. But it's free of that potential race condition, which makes me very happy. All right, so in just a few minutes, we've gone from a mocked out demo to a real app that builds for both iOS and Android with a Cloud Firestore collection on the back end, keeping everybody on the same page. You and your bandmates have what you need to go out and find whether 3 ferrets and a banjo really is the name for you. That's it for today, but if you'd like to learn more about Flutter, we've got links to guides, a step-by-step code lab covering Firebase with Flutter, and a bunch of other resources in the description for this video. So check those out and head to flutter.io to get started.